Yeah, hello everyone. This is Ankit from Kailasha Foundation Fun and Learn portal, and today it is our second lecture of number system. We'll study divisibility rules at first today. Divisibility rules. In this topic, we will study that if a number is given to us, then without actual division, how will we determine that the number is divisible by some particular given number or not? And when we talk about divisibility, we check the divisibility basically by 2, 3, 4, 5, 6, 8, 9, 11. Okay. Beyond this, it gets complicated. So let us understand a few things. 0 is divisible by all real numbers except itself. Okay. 0 is divisible by all real numbers except itself. 1 divides all integers. Okay. 2 divides all integers ending in 2 divides all integers ending in 2, 4, 6, 8 or 0. Okay. 5 divides 5 divides all integers ending in 5 or 0. 10 divides all integers ending in 0. Okay. So divisibility by 2, a number is divisible by 2 or not, we can simply determine from no matter how large the number is 3, 4, 6, 9, 4, 3, 2, 1, 0, 5, 7, 2. The number this large, the number, but the last digit is 2, and what is the rule? Number ending in 2, 4, 6, 8 or 0. So it is ending in 2, hence it is divisible by 2 no matter what these digits are. No matter what these digits are, the number is ending in 2, so it is divisible by 2. A number ending in 2, 4, 6, 8 or 0 is divisible by 2. A number ending in 1, 3, 5, 7 or 9 is not divisible by 2. That's as simple as that. Okay. Okay. Now we'll see divisibility by divisibility by 3, divisibility by 9. These two are very similar. Okay. Let us see a number 1, 2, 3, 4, 5. Okay. Without dividing the number actually, we simply add the digits 1 and 2, that is 3 and 3, that is 6 and 4, 10 and 5, 15. 15 is divisible by 3. So this number is also divisible by 3. Okay. 1, 2, 3, 4. 1 and 2, that is 3, 3 and 3, that is 6 and 4, 10. 10 is not divisible by 3. So it is also not divisible by 3. Now 1, 2, 3, 4, 5, 6. 1 and 2 and 1 and 2, that is 3, 3 and 3 6, and 4 10, and 5 15, and 6 21. 21 is not divisible by 9, so this number is also not divisible by 9. Okay, 9 8 7 6 5 1. 9 and 8, that is 17, and 7, that is 24, and 6 30, and 5 35, and 1 36. 36 is divisible by 9, so this number is also divisible by 9. Okay, so for checking the divisibility by 3, we simply add the digits of the given number and check the divisibility of that sum, sum that is very smaller than the actual number. So to check the divisibility of a given number by 3, we simply add the digits of the number and check the divisibility of that sum obtained by 3. Okay, if the sum is divisible by 3, then the number is also divisible by 3, and the same rule is applicable for 9 as well. Okay, if the sum is divisible by 9, then the number is divisible by 9. If the sum is divisible by 3, then the number is divisible by 3. Okay, now divisibility by 0 is discussed, divisibility by 1 is discussed, 2 done, 3, okay, 4 is remaining, 5 is done, 6 is remaining, 7 we are not discussing because the divisibility rules for 7 are given in various forms in various books, but those are so complicated that in that amount of time you can do actual division and check the number if that is divisible by 7 or not. So we are not discussing divisibility by 7. Thereafter 8, 9 is done, 10 is done, 11 is remaining. So now we will discuss divisibility by 6. A number is divisible by 6 if it is divisible by 2, it is divisible by 3. Both these conditions are necessary for divisibility by 6. The number must be divisible by 2 and the number must be divisible by 3. Number must be divisible by 2 and 3 both. Okay, if the number is divisible by 6, then it is divisible by 2 and 3 both, and if the number is divisible by, that means vice versa. Okay, so for the divisibility by 3, for the divisibility by 6, we check the divisibility by 2 and 3 separately. If both the conditions are satisfied, then it passes the divisibility test. Okay, now we have to discuss 4 and 8. Divisibility by 4 and divisibility by 8. 3 6 5 7 2, 3 6 5 7 2. Okay, for the divisibility by 4, no matter what this given number is, in fact you add a few more digits here to the end, 1 2 3 5. No matter how large the number is, you have to just consider the last two digits. What is this number? 72. Is 72 divisible by 4? 72 is divisible by 4. Yes, 72 is divisible by 4. So the complete number, this entire number is divisible by 4. Okay, 1 2 3 5 3 6 5 7 2 is divisible by 4. So that means 472 is also divisible by 4. Yes. 172, yes. 972, obviously. 8 3 8 5 6 5 7 2, yes. No matter what ending in 72 is divisible by 4. Okay. No matter what ending in 72 is divisible. That means uh, 2, 3, 4, 5, 0, 4 is divisible by 4. Yes. 2, 3, 4, 5, 0, 4 is divisible by 4. Because this is 0, 4, 0, 4 is divisible by 4. So this complete number is divisible by 4. That means 1, 4, 1, 4, 3, 6 is divisible by 4. Yes, because 36 is divisible by 4. So the complete number is divisible by 4. 1, 2, oh sorry. 1, 2, 1, 2, 1, 2, 1, 2 is divisible by 4. Yes. 3, 5. Now, no. 3, 5, 6. 5, 6 is divisible by 4. So the number is divisible by 4. Now, let us check a few numbers here. 1, 2, 1, 2, 1, 2, 1, 2, 3, 5, 6, 2, 3, 4, 5, 0, 4, 8, 3, 8, 5, 6, 4, 7, 2. Now, are these numbers divisible by 8? So what do we do? Do we do the same thing that we did in divisibility by 4? No, no, no. We will take 3 digits here. Yes. A smaller division process is required while checking the divisibility by 8. The complete number is not to be checked, but a portion of that is to be checked. The last 3 digits constitute a number and that must be divisible by 8 for the complete number to be divisible by 8. So 572, 8 5s are 66, 8 5 8 7s are 56 and 8 7s are 56 and no, 572 is not divisible by 8, so the number is not divisible by 8. Now 8 fours are 32 and 3 remains 8 fours are 32 again. The number is not divisible by 8. 8 6 are 48 and 2 remains 8 threes are 24. 504 is divisible by 8, so the complete number is divisible by 8. 8 5s are 40 and then 0 8 9s are 72. 472 is divisible by 8, so the complete number is divisible by 8. Okay, now you'll see something very interesting. Divisibility by 2, divisibility by 4, divisibility by 8, divisibility by 16. Yes, 1 2 3 4 5 6 1, oh sorry, 1 2 3 4 5 6, 1 2 3 4 5 6. Okay, divisibility by 2, only last digit, last 2 digits, last 3 digits and last 4 digits. Wait, what? Yes. Remember what you did while checking the divisibility by 2. The last digit must be 2, 4, 6, 8 or 0. What was that? The last digit must be divisible by 2. The last digit must be 2, 4, 6, 8 or 0. That means the last digit must be divisible by 2. The last 2 digits constitute a number that must be divisible by 4. The last 3 digits constitute a number that must be divisible by 8. The last 4 digits constitute a number that must be divisible by 16 for the respective divisibility checks. Okay. This is how it works because 2 5s are 10. 2 power 1 into 5 power 1 is equal to 10. That is 10 raised to the power 1. One digit. Okay. 2 power 2, that is 4 into 5 square, that is equal to 100. That means 2 zeros, that is 10 raised to the power 2. That's why 2 digits. because anything 1 2 3 4, what is this? 1 2 3 4 double zero. Anything ending in double zero will be automatically divisible by 4. So we have to take care of the remaining 56 only. 1 2 3 4 double zero is something 100, something 100, and 100 is already divisible by 4. So something 100 will be necessarily divisible by 4. So 1 2 3 4 double zero, if we divide by 4, then what remains 56. So we have to take care of 56 only. Okay. In the same way, something 1000 is divisible by 8. So 123,000 is also divisible by 8. So 456 only has to be checked. Okay. So for divisibility by 2, last one digit. For divisibility by 2 power 2, last two digits. 2 power 3, last three digits, and 2 power 4, last four digits, and so on. Okay. So 4 and 8 done. Now divisibility by 11. Divisibility by 11. Okay. Let us see this number 1, 2, 3, 4, 5, 6, 7, 8, 9. Take the sum of 1, 3, 5, 7 and alternate digits and remaining alternate digits. The sum is 1 and 3, 5 and 5, 10 and 7, 17 and 9, 26. 2 and 4, that is 6 and 6, 12 and 8, that is 20. What is the difference? Difference is 6. Is 6 divisible by 11? No. So the number 1, 2, 3, 4, 5, 6, 7, 8, 9 is not divisible by 11. 3, 3, 5, 5. 3 and 5, that is 8. 3 and 5, that is 8. 8 minus 8 is 0. Is 0 divisible by 11? Yes, 0 is divisible by everything. So 0 is divisible by 11. Yes. So the number 3355 is also divisible by 11. We can check it here. 3355. 11 3s are 33. 11 5s are 55. Okay. 1929 1929 4. Okay. 1 and 2 and 4, that is 7. 9 and 9, that is 18. What is the difference? Difference is larger minus smaller. So 18 minus 7, that is 11. So 11 is divisible by 11. So 19294 is also divisible by 11. 19294 is also divisible by 11, and we can check that. 11 ones are 11. Okay. 8. 11 sevens are 77. 5. 11 fives are 55. 11 fours are 50, 44. Okay. So this was the lecture for divisibility rules. Now we will discuss prime and composite numbers. Prime and composite numbers. How to check if a number is prime or not. Okay. So prime numbers, the definition part. Prime numbers, the main thing about prime numbers is a prime number has two factors. A prime number has exactly two factors. The definition starts and ends here. Now, when we go further to explain this, then we realize, then we understand that the two factors of a prime number are 1 and the number itself. One of the factors is 1 and other is the number itself. For example, 7 is a prime number because it has only two factors, and exactly two factors, 1 and 7. 1 divides 7 completely and 7 divides 7 completely. Nothing else divides 7 completely. Okay. We see that 6 is not a prime number because 6 is not a prime number because it has more than two factors. 1, 2, 3, 6. It has four factors. So if 6 is not prime, what is 6? 6 is a composite number. What is the definition of composite numbers? What is the definition of composite numbers? A composite number, a composite number has more than two factors. This is very important. More than two factors. A composite number has more than two factors. Now we will see a few things. Now we will discuss a few things. We have studied two types of numbers here. Obviously, we are talking about natural numbers now. We are not talking about whole numbers, negative numbers, zero, integer, decimal. We are talking about natural numbers only. Okay. When we are talking about division, divisibility, rule, factors, multiples, LCM, HCF, for the sake of simplicity, we are talking only about natural numbers that you have to keep in mind. So, natural numbers, as far as we have studied, we can say that are of two types, prime and composite. Is that true? Think of it. Are natural numbers only of two types, prime and composite? Is that true? And another thing, that prime numbers have two factors and composite numbers have more than two factors. That means a natural number cannot have less than two factors, because either it has two factors or more than two, because if the number is either prime or composite and nothing else, then what can we say? Now there's an exception. What is that? One is an exception. One is an exception. One has how many factors? One has only one factor, one itself. Does it have two factors? No. So it is not prime. Does it have more than two factors? No. So it is not composite. Neither prime nor composite. One is neither prime nor composite. One is neither prime nor composite. That we have to remember. Okay. And a natural number can have either one or two or more than two factors. If a number has one factor, then the number is 1. There's only one case. If a number has two factors, then it is prime. And if a number has more than two factors, then it is composite. Now we have to see a few things. We will consider numbers from 1 to 100. Let's see, composite and prime numbers. We are going to list, we are going to encircle composite numbers first. Okay. Now, all even numbers are composite. Is that true? Is that true? All even numbers are composite? No, 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 no. 2 is a prime number. 2 is a prime number. Okay. So, except 2, except 2, all even numbers are composite. Yes, because all even numbers except 2 have more than two factors, because one of the factors is 1, um, one of the factors is the number itself, and the third factor is obviously 2. So there are already more than two factors, which is not in the case of 2. Okay, so except 2, all even numbers are composite. So we will encircle these even numbers. Okay, so all even numbers are encircled. Now 1 is not prime, so we will encircle 1 also. We are circling all the numbers which are not primes. Okay, so 2 is prime, 3 is prime, 5 is prime, 7 is 9 is not prime. Why? Because 9 is divisible by 3. Okay, so we get a hint that we have to check the divisibility by previous numbers. We get a hint that we have to check the divisibility by previous numbers to check if a number is prime or not. Okay, so 9 is divisible by 3, so 9 is not prime, so 9 will also be circled. 11 is prime, 13 is prime, 15 is divisible by 5 and 3 both, so 15 will also be circled because 15 is not prime, and this entire row will be circled because all these are divisible by 5. Okay, now multiples of 3, 9 and then 15 and then 21 and then 27 and then 33 and then 39 and 45 is already circled, and 51 and 57 and 63 and thereafter 69 and 75 is already circled, then 81 and 87 and 93 and 99. Okay, multiples of 4 are already listed because all even numbers are gone. So no multiple of 4 remains, multiples of 5 are gone, multiples of 6 are obviously gone because multiples of 2 are not remaining there, multiples of 7 we will check. Yes, 7 is something which has to be checked. 7 twos are 14, that is even. 7 threes are 21, 7 fours are 20, 7 fives are 35, 7 sixes are 42, 7 sevens are 49, 7 eights are 56, and 9s are 63. 7 tens are 70, 11 sevens are 77, 12 sevens are 84, 13 sevens are 91, 14 sevens are 98. Okay, now 17 is a prime number, 19 is prime, 23 is prime, 29 is prime, 31 is prime, 37 is prime, 41, 43 are primes, 47 is prime, 53 is prime, 59 is prime, 61 is prime, 67 is also prime, 71 is prime, 73 is prime, 79 is prime, 83 is prime, 89 is prime, 97 is prime. How many primes are there from 1 to 100? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. From 1 to 50 there are 15. Thereafter 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. 25 primes from 1 to 100. 1 to 100 there are 25 primes, and 1 to 50 there are 15 primes. But tell me one thing, Shall we always check a prime like this? We will check the divisibility by 2 and then 3 and then 5 and then 7 and then 11 and then 13 and then... No, that process will be very lengthy. For example, if we have to check a number to be prime as high as 187, or let's say the number is 443, then it will be extremely difficult to check these numbers to be prime if we go with that method. So we go for perfect squares. What is the nearest perfect square less than 187? 13 square is 169 and 14 square is 196. So 13. What are the prime numbers uh, below 13? 2, 3, 5, 7, 11, and let's include 13 also. Okay, let's include 13 also. Now 2 and 5 are already checked. 2 and 5 are already checked because the number is not ending in 24680 and the number is not ending in 5 or 0. So not divisible by 2 or 5. Now divisibility by 3. 1 and 8, that is 9 and 7, that is 16. 16 is not divisible by 3. 7. By 7 we have to divide it actually to check. 7 2s are 14. No, not divisible by 7. Now 11. It is a very small number and we can actually divide by 11 to check, or we have alternate method also. 1 and 7, that is 8. 8 minus 8, that is 0. 0 is divisible by 11, so the number is divisible by 11. So it has a third factor. So it is not a prime number. 187 is divisible by 11, so it is not a prime number. Not a prime. Now 443, closest perfect square is 441, that is 21 square, so 21. What are the primes below 21? 2, 3, 5, 7, 11, 13, 17, 19. We have to check the divisibility of 443 by these primes only. Okay, not 2, not 5. 4 and 4, that is 8, and 3, that is 11, not divisible by 3. 7 6 are 42, not divisible by 7. 4 and 3, that is 7, not divisible by 11. 13 3s are 39, not divisible by 13. 17 2s are 34. 17 6s are 100, no, not divisible by 17. 19 2s are 38, not divisible by 19, so it is a prime number. 443 is a prime number. 443 is a prime and 187 was not a prime. So we discussed divisibility rules, we discussed primes and composites, and third category, neither prime nor composite. uh, how to check a number to be prime. Number of primes from 1 to 50 and 1 to 100. We have clearly noticed that primes are less than composites. Primes are less abundant than composites. Okay, because if there are 25 primes, then there are 75 composites from 1 to 100, and as we go higher, the number of primes decrease. Okay, decreases. The number of primes decreases. Now composites are obviously more than 50% because in any given set, if 1 and 2 are not there, if we start from 3 in any given set, 50% of the numbers are to be even and 50% are odd in any given set, in any continuous set of natural numbers. Continuous set of natural numbers, 50% are even and 50% are odd, and those even except 2 are divisible by 2, so those are composites. And there are many more composite numbers also there, divisible by 3, divisible by 5, divisible by 7. Okay, so composite numbers are much more than prime numbers. Okay, these are a few things we noticed. Now we will take we will conclude this lecture here. Okay, now we will conclude the lecture here. Okay, so in the next lecture we will be studying uh, BODMAS very quickly, and indices, that means exponents. Okay, and the remaining topics that I told you in the first lecture. The entire syllabus of number system is very vast, so we will be taking more than 5 or 6 lectures in this chapter, so you have to be patient for the chapter to complete. Okay, so thanks for watching this video. Don't forget to like, share and subscribe. Tell more and more people that there is Kailasha Foundation, where we are teaching many courses free of cost, and we are solving your doubts also. You can send your doubts to my WhatsApp number, that is 8294600829. Okay, we are also giving you free mock tests, and for that you can for that also you can contact on this WhatsApp number. Remember that this number is not for calling, this number is only for WhatsApp. Okay, so thank you so much. Happy learning. Bye bye. Don't forget to subscribe. Okay, bye.